Hello, Jai Hind everyone. Today I am going to discuss a very important topic of the basic signal and system, that is Laplace transform. So why we are using this Laplace transform? Laplace transform is a very important mathematical tool to solve integral differential equations, right? That's why we are using this Laplace transform, and the formula for the Laplace transform is 0 to infinity. If we have any function ft, then its Laplace transform will be 0 to infinity ft into e raised to power minus k st into dt. Okay, so Laplace fs is given by like this. Okay, so we have lots of topic in Laplace to discuss, but I am going to discuss the important topics of Laplace transform. That is, the number one is the initial and final value theorem. This is one of the property of the Laplace transform on which numericals are very prominent, right? So it is based only on the formula. So today I am going to discuss about the initial and final value theorem, so that you can easily solve out the formula. Because the question could be, if you are preparing for the GATE, you are preparing for any thing, and if you are having exam as well as from examination point of view, your BTech examination point of view, university examination, this topic is very important. Either a formula can be asked or a numerical can be asked on this, based on this, in 2 marks or in 5 marks. Okay, and then I will talk about the how to solve the differential equations based on the Laplace transform, and then what are the transformed circuit components. If I am talking about the university examination, then this topic will cover up almost 10 marks. A question will be based on almost 10 marks on this topic, right? So these are the very important topics of the Laplace transform. So first topic is the initial value and final value theorem, right? So if a function xt and its first derivative, that is dx by dt, is the Laplace transformable of each other, then the initial value theorem, initial value of xt is given by x0 plus, you can write it as the initial value as 0 plus, final value as infinity. Represent the initial value by 0 plus and represent the final value by infinity. So initial value is given by limit s tends to infinity s into xs. This is in terms of s domain, and if you talk about the time domain, then the initial value theorem is given by limit t tends to 0, and this will be xt. Okay, and similarly for the final value theorem, if function xt and its first derivative are Laplace transformable of each other, then the final value will be given by x infinity will be equals to limit s tends to 0 s into xs. Don't forget to multiply by the operator s, okay, into with the function xs, right? In terms of time domain, it will be limit t tends to infinity x of t. See here, this s is the Laplace operator, which is can be called as the complex variable, and its value is sigma plus j omega. Okay, so it is very easy to solve the complex circuits using the Laplace transform. Now let's solve some examples based on the initial and final value theorem. The first point is, the first function ft is given to us, which is 8 plus 3 into e raised to the power minus t. So you have two options: either convert this function ft into Laplace domain, that is fs, and then apply the limits, these, right? Or if it is given to you in terms of time domain, then you can directly apply these two formulas for initial and final value theorem. And if it is given to you in s domain, you can apply these two formulas for initial and final value theorem in s domain, right? Or if you don't know how to, if you forget the formula in terms of time domain or in terms of s domain, then find out its s domain ft in terms of Laplace transform, that is fs. Or if you don't know the ft formula, if you don't remember the formula in terms of Laplace, then convert it into the time domain and then find out the put the formula. Okay, so ft is given to us here, so I am not converting it into the s domain. I am directly putting the formula for initial value. f0 plus can be written as limit t tends to 0 into ft. Okay, so according to this, we have limit t tends to 0, ft is 8 plus 3 into e raised to the power minus t. So if I put t is equals to 0 here, then 8 is a constant and e raised to the power 0 is 1. So I have 8 plus 3 is equals to 11. For final value, it is represented by f infinity and the formula will be limit t tends to infinity ft. Okay, and if I'll put the limit infinity in ft, then 8 is again a constant and e raised to the power minus infinity will be equals to 0. So the value of final value of the function ft will be 8 here. Now another one is given to us in terms of S domain. So I'll solve it in an S domain, right? So the function gs is given to us and I have to find out the initial value of the function gs. So g0 plus will be equals to limit s tends to infinity s into gs. Okay, if I'll put the value here, this is s tends to infinity and this is s into 10 upon s into s square plus 4s plus 200, right? So this s will get cancel out this. Okay, this is s tends to infinity. So if I put here s tends to infinity, then definitely it comes to be 0. So first of all, what I'll do here is I'll take common the s square. Then again also I'll getting the value as 0. So let something upon infinity is 0, right? So the value of g0 plus here is 0. No need to take common. Otherwise, you can take common here s square if it cancel out with the numerator term, and then something upon infinity will be equals to 0. You can use this to avoid the condition infinity upon infinity, right? Now g infinity, the final value will be limit s tends to 0 s into gs, and don't forget to multiply the function with this s, otherwise answer will be wrong. So limit s tends to 0 here s, and this is gs will be equals to 10 upon s into s square plus 4s plus 200. ठीक, so this s gets cancel out here और 0 0 यहाँ पे हो जाएगा, तो 10 upon 200 will be equals to 1 upon 20 will be the final value of the function gs. This is 1 upon 20, na? 10 will get cancelled out. 10 upon 100 will be equals to 1 by 20. Okay. So in this way you can solve the numericals based on initial and final value theorem. Now another is the differential equation is given to us. How to solve the differential equation? See, first, we can solve this differential equation by using the property of the Laplace transformation. Which property? Differentiation property, right? Since you can see this x double dash means d2x by dt2, right? And similarly x dash means dx by dt, right? And the property, the differentiation property of Laplace says that if you have dnx by dt, and it can be, the Laplace of this can be unfolded into s raised to the power n into x s minus s raised to power n minus k1 initial value of x, this is not x 0 plus or 0 minus, right? Then minus of s raised to the power n minus k1, differentiation of initial value, then s raised to the power minus 3, double differentiation of initial value, up to so on till when it comes to 5 4 3 2 s raised to the power 0 and x n of initial value. Thick. Okay, yes, this is the property. So I'll use this property in this numerical, right? So first of all, x double dash can be written as s square into xs minus s into x 0 plus minus x dash of 0 plus. This is only for x double dash. Then I'll take 3 as common and dx by dt can be unfolded as s into xs minus x of 0 plus, and this 2x can be written as twice of xs will be equals to 0. So I'll take xs terms common, then xs will be, and I am taking common, then s square, and this is plus 3s plus 2, right? And I'll put the value of x0 plus and x dash 0 plus in the above equation. So this is minus of s into x0 plus is 2 given to us, right? If it is not given, initial value is not given to us, then you can directly take the value as 0, okay? If it is given, you can put the value. X minus of x dash 0 plus is minus 3, and here also plus 3 into plus minus is minus 3 into x0 plus is 2 will be equals to 0. Okay, am I right? So here xs will be equals to, this is this come out to be minus 6 plus 3, okay? That means minus 3, and udhar jaake it will be plus 3, minus 2s will be equals to plus 2s, and upon this will be s square plus 3s plus 2, okay? Let me once again check the calculation. This is a minus, okay, minus 2s, right? उधर जाके 2 plus x हो जाएगा, ये minus of 3 यानी plus 3, और इधर है हमारे पास minus 3 यानी कि plus minus 6, right? Minus 6 plus 3 will be equals to minus 3, which will become this. Okay, then what I have to do is, we have to solve this differential equation. That means I have to find out the value of xt. Now I can take the inverse Laplace transform of xs so that I can get the value of xt. For finding out the value inverse Laplace transform, what is the first step? The first step is to take partial to do the partial fraction, okay, of this term. So if I'll take factors of this, then the factors of s square plus 3s plus 2 will be equals to s plus 1 and s plus 2. Am I right? This is s square plus 2 and this, yes, the factors, these are the factors. So I can write it as a upon s plus 1 plus b upon s plus 2, okay, taking partial fraction of the above equation. Take, and here what I am having is xs. So it is 3 plus 2s, okay. So 3 plus 2s upon s plus 1 plus into s plus 2 will equal to a upon s plus 1 और plus b upon s plus 2 हमने लिया था. So I am just comparing the two sides by taking the partial fraction, by taking the LCM, okay. There are 2 or 3 methods to solve the partial fraction. So you can use anything to find out the value of a and b. So after comparing here, I am getting a plus b equals to 2 and 2a plus b is equals to 3. So the value of, you can easily use the calculator to find out the values. So I am finding the value of a is 2 minus b, and when putting it in this, then 2 into 2 minus b plus b is equals to 3. So यहाँ से कितना हो गया 4 minus 2b plus b is equals to 3. That means ये कितना आ गया minus b, उधर चले जाएंगे, इधर आ जाएंगे, यानी b is equals to 1 आ गया. Okay, 4 minus 3 is 1 और minus 2, yes, b is equals to 1 आ गया. That means a is equals to कितना हो जाएगा, again 1. a b दोनों 1 1 आ गए, right? Okay, 1 1 आ गए, तो this is 2s plus 3, right? Okay, so I can now xs will be equals to 1 upon s plus 1 and plus 1 upon s plus 2. Now taking inverse Laplace transform of the above equation, you will get the value of xt. So we have the formula for the Laplace inverse 1 upon So the 1 upon s plus a, the formula is e raised to the power minus at. Using this formula, right, I can write the value of xt will be equals to e raised to the power minus t into ut, right, and plus e raised to the power minus k 2t into ut. So this will be the answer. So this will be the value of xt. In this way, you can solve the differential equation given to you. You have to do nothing, only you have to use this property. So this is the important property to remember. Just put the values and just go for the inverse Laplace transform. You will get the value of xt. Now another topic is transformed circuit components. So basically we have three elements in the electrical circuit. What are these? Those are resistor, inductor and capacitor. So the first element is the resistor, right? So if according to Ohm's law, V is equals to IR, am I right? Okay, or I can say VR is equals to IR into R, ठीक, in terms of time domain, ठीक, इसको और properly लिखते हैं, VR of t will be equals to IR of t into R, right? So you can draw this circuit. Vt is given to you, It is flowing here and this is R, right? So accordingly you can write this equation. If we talk about the Laplace transform and we'll take the Laplace transform of this equation, then I can write VR of S will be equals to R into IR of S, right? So according to this equation, the Laplace transform circuit will be similar to the circuit in time domain. Only the voltage source and the current source values will be in terms of S domain, right? So this is the circuit. So there is no change in time domain and in S domain for the resistance R in the circuit as well, right? Now if we talk about the inductor, inductor is represented by the circuit element L. Inductor is the circuit element which is represented by the L. Okay, so we know the equation, the V and I relationship for the inductor will be V is equals to L into di by dt, or I can write it as VL will be equals to DIL by dt. It is in terms time domain, okay? And in terms of the current equation for inductor will be 1 by L integration of VL of dt, ठीक है, ये. So accordingly the circuit will be this. There is an inductor and we have VL of t और current यहाँ से flow हो रहा है IL of t, let's say, and it is L. So VL is equals to L di by dt, ठीक है. Now if we take the Laplace transform of this term, right? So what is this? VL of S will be equals to, we'll use the property of differentiation here, okay? Taking L as common, and what will be the property? S into IS, ISL, right? Minus K I 0 plus, ठीक है. तो इसको मैं ऐसे लिख सकती हूँ, VL of S will be equals to SLI of L of S minus K L of I 0 plus. So आपको डिफरेंस क्या दिख रहा है? वोल्टेज इक्वेशन इन टर्म्स ऑफ टाइम डोमेन में एंड वोल्टेज इक्वेशन इन टर्म्स ऑफ एस डोमेन में. द एक्स्ट्रा वोल्टेज सोर्स इज एडेड हियर ऑफ द अपोजिट पोलैरिटी, ठीक. तो इसके लिए सर्किट क्या होगा? नाउ इन टाइम डोमेन अगर मैं इसके लिए, इस इक्वेशन के लिए यहाँ पे सर्किट ड्रॉ करूं तो हमारा सर्किट क्या होगा? द वोल्टेज सोर्स इज अप्लाइड एट द इनपुट टर्मिनल और करंट यहाँ पे फ्लो कर रहा है, राइट? एंड वी हैव इंडक्टर हेयर, उसकी वैल्यू क्या हो जाएगी? L will be converted into SL, ठीक. Now this is the, what is this? It's a voltage, right? We have to make a voltage source here which is of the opposite polarity, and the value of this voltage source will be Li 0 plus. Now you can write this equation from the circuit. एक मिनट, माइनस उधर जाके प्लस हो जाएगा ना. ओके राइट. नाउ इफ वी टेक द Laplace transform of the current equation, then you can see then IL of S will be equals to, I'll use here the integration property. Okay, then this will be 1 upon SL VL of S plus the integration constant which will be, क्या वैल्यू थी उसकी हम मान लेते हैं, लेट्स से करंट की टर्म्स में होगी, दिस विल बी IL 0 प्लस अपॉन S. ठीक, ओके, क्योंकि ये करंट की इक्वेशन है. तो अब इसके लिए भी अगर आप देखें तो वी हैव एन एक्स्ट्रा एलिमेंट हियर विच इज द इनिशियल वैल्यू ऑफ द करंट अक्रॉस द इंडक्टर. तो इसके लिए हमारा सर्किट क्या बनेगा, we have again the voltage source at the input terminal or current IL of S is flowing here. Then we are having two terms in parallel. One is the inductor, ठीक, जिसकी वैल्यू क्या है SL, ठीक है, और ये करंट IL is coming here and वोल्टेज इसके पैरेलल में हो जाएगी VL अपॉन SL. एंड यहाँ पर हम क्या लगाएंगे, एक करंट सोर्स which is करंट इधर से फ्लो हुआ, IL is equals to incoming current is equals to outgoing current. तो इसकी वैल्यू क्या हो जाएगी यहाँ पर हमारी, this downward arrow towards downward and IL 0 plus upon S. So in terms of if I am writing the current equation in terms of inductor, then extra current source will be added in the circuit in parallel with the inductor. And if I am writing the current voltage equation in terms of inductor, then an extra current voltage source will be added in the circuit which is of the opposite polarity of the ठीक है. Next is the capacitor. So capacitor is represented by the element is represented by symbol C, and if I am writing the voltage equation of capacitor in terms of time domain, then the equation is 1 upon C integration of IT dt, right. और current equation क्या हो जाएगी, इसको IC कर देते हैं, ICT will be equals to C dVC by dt. ठीक, तो अकॉर्डिंगली कैपेसिटर के लिए अगर हमारे पास यहाँ वोल्टेज इनपुट पे भी है VCT, करंट इज फ्लोइंग ICT, then this is the capacitor in the circuit and this will be the diagram for the capacitor, right. Now if I'm taking the Laplace transform of this equation using the Laplace integration property of the Laplace transform, then VC of S will be equals to 1 upon CS IC of S plus the initial value of this VC 0 plus, right, and for the constant we have 1 upon S in Laplace domain, right. तो इसके लिए now again you can see I have an extra voltage source here. I have to put an extra voltage source. इसके लिए हमारा सर्किट क्या बनेगा now, एक मैंने VCS एक वोल्टेज सोर्स लिया है यहाँ पर और एक करंट सोर्स, मेरा करंट फ्लो कर रहा है ICS, तो मुझे एक कैपेसिटर जिसकी वैल्यू क्या हो जाएगी 1 upon CS, and I have to add an extra voltage source which is having the same polarity, right, which is having the same polarity as that of voltage source applied at the input terminal, and the value of that voltage polarity will be VC0 plus upon the S. ठीक, if I take the Laplace transform of the current equation, then IC of S will be equals to C into S. I am using again the Laplace differentiation property of Laplace which will be equals to यहाँ पे IC 0 plus, ठीक है, and when I'm simplifying it then it will be VCS minus C into IC 0 plus. So it's a current equation. So when I have to draw the circuit for this equation, then I have to add an extra current source in parallel with the capacitor whose value will be equals to C into IC 0 plus. So this will be plus and this is minus. So you can see here 1 upon Cs. Okay, IS incoming current will be equals to the outgoing current. The two currents, this is the incoming current through this node and this is also will be equals to this. Okay. So these are the circuits for the capacitor. Now let's solve the example. So this is the summary. When how this inductor and these initial conditions, how these initial value of the current and the voltage across the inductor and the capacitor behaves in the transient condition or the initial condition or in the steady state condition, that is in the final condition, right? So for resistor it will remain same. Resistor will behave as R. It will neither behave as a short circuit or neither as a open circuit in terms of the initial transient state or in the steady state, right? So R remains. Let's talk about the initial conditions first. So for the all the elements as well as the two sources, voltage source and the current source. So R will behave as it is, it will remain same R. Now inductor will behave as an open circuit in the initial state, that is the transient state, and the capacitor will behave as the short circuit in the transient state. And the current is represented by simple current source and the voltage is represented by simple the voltage source in the initial state. But in the final state or the steady state, right, the inductor will behave as the short circuit and the capacitor will behave as the open circuit. And if we have the current flowing across the inductor, then the current source will be connected and the inductor will behave as a short circuit, right? An additional current source will be added here. Similarly, if we have voltage source across the capacitor, then in the final state this voltage source across the capacitor, okay, will additional voltage source will added in series with the capacitor and this capacitor will behave as open circuit. Similarly here, if current is flowing across the inductor, then inductor will behave only a current source will be represented here as open circuit is shown here, right? For the capacitor only a voltage source can be represented by a voltage source in the initial condition. So we can use these values in our numericals. We should remember especially these two values, how inductor and capacitor behave in initial and final conditions, right? Inductor will behave as open circuit in initial state, right? Now let's solve some example. We have to find out the value of I di by dt and d2I by dt2 at t is equals to 0 plus. So the circuit is given to us in this network. The switch is closed at t is equals to 0, right? This is d2I and this is d22, right? With the 0 current in the inductor, find the value of I di by dt and d2I by dt2. Okay? So when before t is equals to 0, that means at t is equals to 0 minus, switch ही नहीं close हुआ है, that means switch is open. So the value of I 0 minus will be equals to 0 because switch is open. Now when at t is equals to 0 पे, when switch is closed, right, then this will be the circuit, right? And in that case, let me talk about t0 plus पे. This inductor will behave as let me draw this circuit. This will be the circuit at t is equals to 0 plus 100, and this resistor will remain same as 10, and this inductor will behave as open circuit, right? So in this case, the current I0 plus again will be equals to 0, okay, because inductor is behaving as open circuit. Now at t is equals to 0 plus, when at t greater than 0, right, this will be the circuit 100, then this resistor, switch is closed, this is 100, this is the resistor 10 ohm and this is inductor 1 Henry, okay. So when this current I is flowing here, let's say this is IT, I can write the KVL equation 100 is equals to 10 IT plus 1 into di by dt, okay. ठीक है. और what I have to find out, एक तो I0 plus find out करना था, di by dt find out करना था, तो यहाँ से di by dt will be equals to 100, what is this, 10 into it होगा, sorry, 10 into it. ठीक है. तो this is equals to 100 is equals to 10 it. So di by dt from here will be equals to minus 10 times of it, ठीक है, is equals to di by dt. Now what I have to find out, di by dt at t is equals to 0 plus, right? So put t is equals to 0 plus. So di at 0 plus by dt will be equals to 100 minus 10 into I 0 plus, and the value of I 0 plus here is 0. So I can put the value of I 0 plus is 0. So di by dt at 0 plus will be equals to 100 ampere per second. This is ampere for the current and per second for this, right? Now what I have to do, we have to find out the d2I by dt2. Now see, taking this, now differentiate equation 1. So if I differentiate equation 1, I'll get d2I by dt2 will be equals to, since 100 is a constant, minus 10 it, right? So this 100 will become 100 of it minus this is 10 di by dt. ठीक है. 100 constant का क्या होता है differentiation, 0 होता है, sorry. ठीक है. तो 0 minus di by dt. Now at t is equals to at d2I at t is equals to 0 plus by dt2 will be equals to minus k 10 di at 0 plus. Put t is equals to, what I have done is put t is equals to 0 plus. तो di by dt at 0 plus कितना आया था, 100. ठीक है ना, उधर माइनस भी था, तो इसकी वैल्यू आई है 100. तो d2I 0 plus at dt2 will be equals to minus k 10 into 100. So I am getting minus 1000 ampere per second square will be the value of d2I 0 plus at dt2. ठीक है. So this is it for today's lecture. So you can also solve, I have done it through the classical method because only the value of d2I and di and dit at 0 plus is found, needs to be find out in this numerical. We can use Laplace transform as well for if we have to find out only the value of it. ठीक है. So that's all for today's lecture. Thank you.